Given A equals the 2 by 2 matrix with elements 1, 0, 0, and -1, find A squared, A cubed, A fourth, and A to the nth power. We'll start with A squared, which we know is A times A. So we're going to have to use matrix multiplication here to find the product of A times A. Because we've got a 2 by 2 matrix times a 2 by 2 matrix, we know we can multiply them because the inner dimensions are equal, and then our result is going to be another 2 by 2 matrix. To find the entries of this 2 by 2 matrix, we need to take inner products. For the first entry, we'll take the inner product of the first row and the first column. 1 times 1 is 1. 0 times 0 is 0, and 1 plus 0 is 1. For the next one, we take the inner product of the first row and the second column. 1 times 0, 0. 0 times -1 is 0, so we've just got 0 there. Similarly, we're going to have 0 for the third entry, because we've got 0 times 1 and -1 times 0. For the last entry, we've got 0 times 0 and -1 times -1. So that's 0 plus 1, which equals 1. So A squared is the 2 by 2 matrix with elements 1, 0, 0, and 1. Let's take a look now at A cubed. A cubed is A times A times A. Well, we know that A times A is this matrix. So we just need to take this matrix and multiply it by A, which has elements 1, 0, 0, and -1. Again, we've got a 2 by 2 matrix times a 2 by 2 matrix, which gives us another 2 by 2 matrix, and we'll use inner products to figure out the entries. For the first entry, we've got the inner product of the first row and the first column. We've got 1 times 1, which is 1, 0 times 0, which is 0. We add them up and we get 1. For the next entry, we've got 1 times 0 and 0 times 1, which is 0. The same is going to be true for the lower left entry, but then for the lower right entry, we've got 0 times 0 plus 1 times -1, which is -1. So notice when we take A cubed, we end up with a matrix that has the same entries as A, so A cubed is just equal to A. This will be helpful when we look at A to the fourth. A to the fourth is A times A times A times A, but A cubed, we've already figured out, is equal to A, so this is just A times A. And we know what A times A is because we've already done it. It is the matrix with elements 1, 0, 0, and 1. And hopefully you're seeing a pattern here. We started off with A, and then A squared, and then A cubed was equal to A again, and then A to the fourth was equal to A squared. We have got a pattern, and the only thing that's changing is the element in the lower right-hand corner. So if we want to look at A to the nth power, it's always going to end up being a matrix with elements 1, 0, and 0. And then here in the bottom, this is either going to be a positive 1 or a -1. And it's interesting, there is a way to write this. We can actually write this -1 to the n power. Because when n is 1, -1 to the first is -1, which fits. When n is 2, -1 squared is +1, which fits here. And in fact, anytime n is even, a negative number to an even power is positive. And we can see with these even powers of A, we've got a positive down here. And then a negative to an odd number is negative. We can see that when we're looking at an odd power of A, we've got -1 down there. And so this is a way for us to express what A to the nth power is, depending on whether n is even or odd.